if you need to buy the Cadence or Synopsys licenses, it's quite expensive. It gets easier and cheaper to build your own chips. So I think we will see chips actually from smaller companies, and they are probably looking for open source alternatives instead of buying expensive IP cores.
Today, I'm talking to Daniel Schultz. Daniel is the founder of aesc Silicon. It's an open source semiconductor design startup. It's based in Frankfurt, Germany. In the last few episodes that we've done, the Siliconomist has been going deep into open source semiconductors. So I'm trying to understand the infrastructure, the players, and maybe most interestingly, the business model behind open source silicon. So in the last few episodes, I interviewed Matt from Tiny Tapeout, and I interviewed Tim from Waferspace. They're both running important sort of like fulcrum points in the open source silicon ecosystem. And today I'm excited to welcome Daniel. He's here to talk about his company, his entrepreneurship journey, and how open source silicon actually works at the business level. Big question is like, how do you build a company on something that's free? So Daniel, thank you so much for joining me. It's really great to talk about aesc Silicon.
Thanks for inviting me.
Where did the name aesc come from? I thought it was an acronym at first for something, but is there a story behind it?
There is a story, but yeah, there's one. So I like actually company names like Detroit Motors, American Construction Groups, like where the name of the location is included. I just think they sound great. I'm from a town in Germany where it's one of the rare spots where we have snakes. And aesc is actually, I think it's called Aesculapian snake. So the first feather. Also good because it's an A and an E at the beginning. Okay. So you always at the
puts you right,
top.
Right at the front. That's very practical. I like that.
It is.
Tell me, so aesc Silicon, tell me just a little bit, like give me a general sense of the business model and how it operates. Like, tell me like who are your customers and what are they looking for with open source silicon?
Okay, yeah, aesc Silicon is a fabless semiconductor startup. I just founded in January this year.
Congratulations.
And the strategy is open source first, basically.
Okay.
And yeah, currently I don't have any active customers like selling chips to. I'm working a lot with contracts right now. And in parallel, I'm building up infrastructure. Yeah, working on projects, open source projects right now to switch to active customers at some point.
When you talk about working on projects, I know you're pretty active on Open Road and a few other projects as well that I think kind of scaffold open source design, right?
Yeah, that's true. More on the Open Road flow scripts, on the flows. I'm trying to do more on Open Road itself, on the EDA tool, but that's a harder part. It's a complex tool.
Yeah.
But yeah.
What is the EDA? Sorry, which EDA tool is that?
Open Road is the EDA, like this is a replacement for Cadence, for Synopsys, for Mentor. So that's the tool to generate the layout files.
And so you started the business in January. You're looking at customers that would be interested, or like the open source silicon offers them some sort of edge for them, right? Like they're looking for that preference, or why would they be looking for that preference? I guess why are they looking for open source?
Yeah, right now I think everything is more expensive probably right now because all the technology is available. So, but there's a whole business like security, for example. Normally security is more safe if it's open source. I think critical infrastructure is important because you never know what actually got added to your design after you sent this to the fab. So the open source, you can actually still verify, make sure this is safe.
Is that so? If you have an open source chip, maybe the security is more auditable. Like if I want to know, like you said, something could be added in later, but if it's open source, I know from start to finish all the ingredients.
Yeah, and for like if we have like cryptographic algorithms, they are all open source now because you don't trust anyone doing cryptographic algorithm for you. And that if you buy an cryptographic engine or accelerator and you don't know what's inside, you don't know if it's really secure.
Yeah.
A huge advantage.
I wouldn't think of that. That's a good sort of total customer, I guess, to start with. And And are you, if I understand right, you're running maybe the Red Hat model, source code will be open and then services are what customers actually pay for. Is that right?
That's correct. Yeah. So a little bit background about me. I'm actually a computer science. I studied computer science. I'm a software engineer for almost 10 years as an embedded software developer. And I'm pretty familiar with this model because Linux is a multi-billion-dollar industry. Works well. Open source is very new to semiconductor. So yeah, the
Yeah.
idea is provide open source IPs, chips, but open source is not always ready to use in your final product. So you need professional services to make this, to adapt new features, to more verification, or even you need support at some point, because we know it's easy to make a product, but you also need to maintain and support products later. So
That makes a lot of sense. Yeah. So you have open source IP cores, and you'll bring those, help a customer select them and architect them, if you will, bring them together. And that is the services sort of bringing them together with the final design, and then doing the design verification and maybe a firmware layer after that. How does that work?
that is correct. Yeah, you have the bare IP core, but some customers, they might need special features because the product has special requirements. So then there are external contractors who can do that.
Correct me if I have this wrong, but Red Hat and Linux, they worked kind of as a business model because so many businesses depended eventually on Linux, right? So many of the businesses end up having this vested interest in keeping security up to date and building improvements. And that kind of blew up when you had sort of cloud services came to bear, and then phones and like Android systems started to run them. And we had a lot of more embedded systems out there that would also run Linux. And that made businesses interested in contributing back, patching security, and sort of paying for stuff. If you look down the road, what's the demand in the future that kind of drives that silicon? Like, what's the analogy to mobile phones and
hmm
to cloud infrastructure that really gets businesses investing in open silicon?
Yeah, so my prediction, or what I think is, since we have no open source tools, the burdens to make your own chips get lower. Because
Yeah.
if you need to buy the Cadence or Synopsys licenses, I mean, I can't tell you prices, but it's quite expensive. So and it gets easier and cheaper to build your own chips. So I think we will see chips actually from smaller companies,
Hmm.
and they are probably looking for open source alternatives instead of buying expensive IP cores. Since I think the Linux Foundation analyzed the return of investment on open source and said it's like 4 to 6 times. So
Wow. Okay.
yeah, it's like huge. And I think for small companies, if they contribute similar to Linux, can use these IPs for free, but they also might have like engineers working on these and contribute back. So I think there will be a bigger demand from smaller companies like Apple with a big budget, on Nvidia.
Yeah.
I don't think their business model will change.
You're going to stick with Synopsys and with Cadence,
Yeah,
but
I mean the
yeah.
price the price for those EDA tools and licenses is so low in these big M5 chips they're building right now and whatever. So
Yeah.
I think
So the diversification, or just the fact that there are going to be more and more companies that are going to build chips and do their own custom designs, that's a good idea. Maybe that's what drives open source silicon and helps the model kind of take off. So on one hand, your tools are lower, right? So as a startup, you don't have to pay for the $100 to $500,000 seat per year to rent
yeah,
the software, right? That's a nice lower barrier to entry. But on the backside, you can't build out proprietary IP blocks, right? So that you don't really build that moat as you go. Do you think that limits like how you grow and where you go? Another, say a traditional design firm, I assume would like own some IP blocks at some point, and that would be something that can redeploy and relicense. And it seems like that if you're working entirely in open source, do you still have that option?
that's a good question because technically it's open source, so you cannot dance this. But the point where you make revenue or that will shift. So I have a IP provider who is investing all the money, and basically all its designing, verification, silicon proven, etc. But they also get the entire revenue, and that will shift, and maybe that's spread it to multiple companies in the future working on designs. Yeah, I don't think there will be any license fees in the future for those IPs because it's technically impossible for probably because of the open source license.
You start with open source IP blocks, and so you don't have to license them. Another expense that you avoid working in open source, right? But
Yeah.
on the backside, any IP that you develop, you don't have the opportunity to maybe to build those and license those in the future. And so
No,
it
but
continually depend on
engineering tasks or
yeah, exactly. Yeah.
but there's
Consulting
also
businesses. Yeah.
yeah, but there's also, for example, support contracts for these.
Okay.
So you can also sell support contracts for IPs because they might need support. Like they have customer issues later, and then you need to help support them.
Yeah.
Yeah, but that's the business model will shift to more like what Red Hat is doing. But Red Hat is also making a lot of money with maintenance, support, and all this.
Certainly a profitable business. That makes
It's
sense.
just
And
different.
the way to scale for Red Hat or for any, it's like if consulting is kind of the business, the way to scale is to add customers, but then also you have to add headcount.
Right.
To grow, you'll have to hire more engineers.
Not right now because I'm still trying to figure out where the open source
Yeah.
direction is. But yeah, I'm thinking about this. That's why I also have no VC funding right now because just trying to figure out what's working best.
You're designing stuff right now. We talked a little bit about toolchain, the tools you're using. Saw Open Road. I saw on your GitHub when I was kind of exploring that. Tell me, like what are the tools that you're using right now to build in the open source space?
Yeah, that's mostly Open Road flow scripts, which is a open source collection of basic flows. And this is using Open Road, the open source EDA tool to do. And then they're using also a lot of K-Layout, which is an open source GDS viewer, basically.
Okay. GDS lets you do like a 3D design off of your schematic layout. Is that right? Or
yeah, that's I think technically it's a 2D collection of layers, but it's basically to open the final manufacturable file for the fab.
do you end up contributing back to Open Road or to any of the other tools that you use?
Mostly to Open Road, yeah.
Yeah.
K-Layout is working pretty well. I think that's also an older tool. It's used a lot right now, I guess, since there's more demand. Yeah, I'm contributing back to Open Road flow scripts and to the IHP PDK. I'm using that a lot.
IHP, they have the open source PDK for their Foundry, right? And
that's
you're able to contribute back to that.
Mm-hmm. Yeah, that's it's a research facility here in Germany, and they have one of the 3 open source PDK.
So when you think about what you're missing out on with like Siemens and Synopsys and Cadence, we mentioned cost on your website, like on Ask. There's also, you talk about vendor lock-in, right? And that's like another reason not to use closed source tools. I kind of conceptually understand why that's bad. I guess if you want to change later on or hop from one to the other, that is the danger of vendor lock-in, or it's expensive to do that. Is that right?
That's right. I don't know if they're compatible at all. So you need to update your flow. But you have the same with the EDA tools and the IP cores.
Yeah.
I mean, we have now a lot of political discussions about US, Europe, for example. We are aligned, but still, who knows what's happening in the future?
Yeah.
There are countries that have no access to these tools at all or to these IP cores. There's restrictions.
Yeah.
You see China is heavily investing in RISC-V and open source 2 because they want to be independent. And it could be your company gets blacklisted and then you get no IPs anymore or tools. So it's also freedom.
Yeah. That makes sense too. Yeah. Just some political risk to take off the table.
Probably not the big thing, but
well, no, for China For China, it certainly
Yeah,
is. But yeah, you're right. If you're in Europe, then it's possible.
you also
Anything's possible these days.
you also see a lot of people from Chile, for example, now doing tape outs with the IHP process, and I
Really?
think that's a country that's not known for making a lot of chips. See a lot
Yeah.
countries in Africa, South America doing chip designs now because it's affordable and they have no restrictions.
What when you think about the where the open road and versus uh like Cadence, Synopsys, Siemens, right? What do you think you're missing out on right now? Like open source tools, are they ahead? Are they behind? Is there anything that you're missing that that you can't get through those tools?
Yeah, I mean, open source. I think they are not working well on these cutting edge technologies, and that's why you have to pay for one of the big commercial tools right now. For the open source one, they're working pretty well. It seems like the sign off process, so everything after Open Road is a little bit custom for
Okay.
each PDK right now, and speed. But this is just a matter of time and effort to put into these tools.
Yeah.
There's also a lot of you always should double check what Open Road is generating. It could have some issues, could include bugs. That is
Okay.
right now still normal, but it's easy to mostly.
Do you think, I mean, so yeah, I'm guessing there are less people, or are there more people maintaining Open Road right now than some of the larger tool or like the private tools?
I think there are less. Yeah.
Yeah.
I don't know how many people working for Cadence on these tools, but
Yeah.
I guess it's less. Yeah.
Tens of thousands. But I mean,
Yeah.
yeah. If you could sort of wave your magic wand at the tools in the open source chain right now that are missing, what would you solve? Like, is there anything in particular you'd solve, or anything you'd try to make better or catch up with?
Probably speed. That's the most annoying part for me. It takes a long time to build chips. That would
It
be
just takes a
nicer
long
to.
time to
Yeah.
run the designs, or to
Yeah. Yeah.
okay. Huh.
But it's also very complicated.
Yeah, for sure. Well, so projects, like things that you're working on right now, then too. I saw, again, I was snooping around on your GitHub and I saw IP Forge. What does that do? And That's recently made a contribution or set that up. Yeah.
That's a pretty new project. Yes, not announced at this time,
Okay. Sorry.
but it's public already. No, that's
It's
fine. I'm
yeah, I was
gonna
gonna say it's up on GitHub. If you don't want to talk about it, we can skip it.
kind of announce it now. No, so the idea is to I have some. There are some open source IPs. I also have some, and the
Yeah.
idea is to provide these as ready to use blocks you can integrate into your design.
Okay.
So this is the project is basically two parts. One is generating these blocks. It's using Open Road right now. It's doing then tests, verification, etc.
Yeah.
And then you can package those, and they are stored in a Cloudflare, like an S3-like bucket.
Okay.
There's another tool that's called IP Forge. It's a Python tool. So you can download this, and this is an IP package manager, basically. So you can look for IPs. You can download them. You can also manage to see, oh, there's a new version I can update. This, again, is all open source. Even the server side is open source. If someone wants to set up their own IP infrastructure, they could also set their own. It has a configurable registry URL, so you can provide your own IPs.
Okay. So is this like npm or another software tool for importing blocks of IP into your software? Is that, or into your
That
design?
that's
That
basically the idea. Yeah, you can
yeah.
search for digital I2C controller, and then there's one for
Okay.
Sky One. Then you
Okay.
can download, and you can later also update if there's a new version with bug fixes.
Does it does it help you discover IP blocks, or is it just a matter of helps you import them?
No, there's also you can search online for those IPs if you are looking for I2C controller. You can actually filter for those.
Oh,
Yeah,
great.
currently has only the GPIO because I want to get the infrastructure up, but then plan is to expand and also add analog designs, mixed signals.
Huh. That's great. Is an internal tool now. Are you building it like, will it be a community resource, or are you going to keep it internal? Obviously, it's
No,
up on GitHub, I guess, but yeah,
it's
share for
public and
everybody.
it's it's public and should be open source. And yeah.
Yeah. You also, so I think you mentioned earlier GDS fill. Is that right? Or, and Blender GDS was another tool that you use, right? Yeah. Tell me more about that. You put 3D modeling application together for chip design, right?
Yeah. So there was already a project on a repository in GitHub with converted GDS file. So Blender is a tool to visualize designs. And they import for GDS too, but you can import STL files for the 3D printer. So someone had the idea, let me convert GDS files to STL. I was a little bit annoyed by doing all this process. So then I wrote an extension for Blender to import GDS2 files directly. And now if you install this, you can include your GDS2 files and you can render with the Cycles engine. So it has like ray tracing, like shadows, and it's really nice for marketing, for research, if you want to show these very small designs.
Yeah. I think that's how I first saw you. People were sharing designs that you made on LinkedIn around. And I was like, oh, this nice view of somebody's design. That's kind of cool. So
yeah, that's
yeah.
awesome.
So like you said, it's good marketing. It's effective, right?
It's only
People see
possible
it.
because it's open source. Otherwise, you're not allowed to share, which is also a
Yeah.
great advantage.
Do you, so, yeah, we mentioned RISC-V. I know you work, you have another project on that. Is it LMRV? I'm not sure how you pronounce that, but what is LMRV?
LMRV, yeah. RV is the short for RISC-V, yeah. Yeah, so that's an end-to-end open source RISC-V microcontroller project. I figured out it's hard to say it's an open source microcontroller design, but then people think it's just the design. So end-to-end is from the design to final chips on your desk. So it's fully end-to-end open source. And the idea is to have multiple classes or tiers of RISC-V microcontrollers can proven ideally. So people could technically just tape out these or use the layouts. And currently have two classes available, these low and the high tier microcontroller designs. And that's the idea, to provide ready to use microcontrollers.
So will you provide that as a service then through, or sorry, as a product through, yeah.
Mm-hmm.
To your customers? Is that right? They'll just be able to come along, pick it off, and then you'll customize it for them with whatever peripherals they want.
Two things. What I said, ideally there's a ready to use chip you can just buy. So that's also planned to sell those which are currently LMFE configurations. So you can buy those. Even though they are open source, you still need to produce them, you need to package them, you need to test them. So there's a lot of things you need to do. And this is like the service. And the other option is you can use these class and make adaptations like you want different peripherals. You can just swap them and do a custom configuration of one of these chips, which still is cheaper because you get all the entire platform is already proven it works. Just have to pay for these small changes and the entire production, testing, packaging. That's the idea.
It's an interesting project to dive into just a little bit. You have this sort of prepackaged microcontroller, and then I would show up and say, I want like a lot of JTAGs, or I want JTAG and I2C or something, like to name those kinds of peripherals, or maybe analog to digital inputs or something, right? What kind of customer comes to you and says, I have this custom need? Where, as opposed to say just pulling a TI or an ST Micro pre-made microcontroller, because they have so many different variations. You may not have had that come yet, but what do you think that is? Like, who's doing that? Is it a car? It's a car manufacturer, or is it somebody making a custom drone? Or
yeah, that's a good question. I think those are probably industry partner with special requirements. If you build a 3D printer and you want to make it faster, or there's specific requirements and there's no chip available, or you want to build drones and it's not the price, but your final product has this very specific requirement. Going to TI or ST for custom chips is possible.
Yes.
So I think that's industry partner with probably lower demand than like high volume, like millions of chips. That's why I'm not sure the car industry will be one of the customers.
So if somebody needs something really outlandish, like I need 150 A to Ds on one chip or something weird like that. Is that where we enter the market?
Yeah, that's what I think. So these
Okay.
very unique requirements.
Yeah. Oh, that's cool. I can see that. Like definitely TI's MOQ is probably in the millions for you to go ahead and get your own
Yeah,
change of a chip, right? So that puts a lot of people out of that market. So Daniel, tell me, like, entrepreneurship. You had a steady paycheck. You started out working at like an established design firm. What made you leave, and what made you go into the wild world of being an entrepreneur?
yeah. I think probably two things that made that happen. One is, as I said, I'm working on LMIV, and LMIV, the first tape out was 2 years ago.
Okay.
And that was actually Europe's first end-to-end open source RISC-V microcontroller in Europe. So, um, and that was me at home on my private computer in my spare time, and
Yeah.
not Infineon or other big companies. We have a lot of big companies here in Europe, but it was
Yeah.
just me, and I was like, I mean, it's not an industry standard microcontroller, but it can boot some C code. So I thought that's nice.
That is. Yeah.
Then I figured out I'm working more and more on open source chips. I used to work on FPGAs before that, and I don't think I touched FPGAs like since 2 years now, except for verification. I'm working only on open source design, and it's just fun working in this community. So I mean, it's probably not the time to make a lot of money now, but open source will be a thing, and it's
Yeah.
fun, and I think why not?
Some combination of owning your own, being able to work on the projects you want to work on, right? What surprised you, just running your own business and running your own company? What surprised you the most about that leap?
Hmm. Um, the most, I mean, it's nice to have a lot of conversations with people asking, like, I had a lot of calls with people. It's nice to meet new people. You also have to do a lot of, in Germany, I have a lot of stuff with the government and all this stuff. That's um it's different, definitely, but it's fun so far.
I noticed that I was still getting used to that in even in your email signature, you've got your company number and you know uh, real identifying stuff about your company, which is like to an American is a little bit strange because we don't have the same overhead sometimes, I guess. But you know, right on. If
Yeah,
you can cut through that, that's really awesome.
it's a legal requirement here, I think.
It probably means you have even more conviction about your ability to start this company and the business behind it because the starting energy is even higher.
It
Yeah.
was very like not as spontaneous, but last year at some point I was, "Yeah, let's do it," and then it's easier if you just if it's done.
Yeah. Right on.
But it's also good to have a legal entity for I can now pay tape outs for my company, not for my private money. So it's I think tax wise, it's easier to do this, and it's protecting all my projects right now.
Yeah, that's great. You've got real expenses there for doing tape outs and stuff too. Like it's not just a random
Yeah,
coffee here and there.
that's
It's a
true, and
real
they can be
bit of
expensive.
money. So I'm trying to learn more about silicon design and semiconductor design. Where would you send someone who wants to learn more right now about, especially about open source chip design, like sort of from scratch? Where's the best resource, or what's your favorite these days?
Okay, so where I would, I mean, you should probably learn Verilog or design. But that's basic. So there are a lot of books available. Then I would probably download OpenRoad flow scripts, or as an alternative, there's also LibraLane, which is based on top of OpenRoad 2, but it's a different flow.
Hmm.
But for OpenRoad flow scripts, there are designs you can just download, and you can build example designs. And that's probably a good first step. So if you have your first layout done, and for your own design, I always recommend starting very, very low. Build a very small chip, include a counter, toggle some pins. That's it. Go through the entire flow. There's a lot of things you can learn that you
Yeah.
can do wrong. So don't start with a full Linux capable microcontroller because yeah, just slow, tiny, simple design. And it's also faster now. So you can build one of these very simple designs in like several minutes.
I was really inspired. Was talking to Matt mostly was like, oh, we should just, you know, to hop in and take one of these courses or to run some silicon. It's less than a college textbook. So makes you need,
Mm.
and you learn a lot more. So
Yeah, I think Tiny Tapeout is also a very good source to learn and to dive into basic designs now. You see a lot of cool designs right now. You see people building Linux capable designs now. Tim is doing the wafer space, so we go a little bit into the semi mass production right now. That's great. Okay, I get the missing piece right now is probably some fabs, open source, like in 50 to 60 ish
yeah.
nanometer PDK. I think that will be a huge game changer in the future
Hmm. Okay.
because we're right now a little bit limited on speed because 130 and 180 nanometer is quite old.
One of the things that Tim said was, is he talked about getting the first foundries to do an open PDK. Like before that, nobody else would open source them.
Yep.
And I think that the sales pitch that he offered was it'd just be different. You have updated node size. You're not going to win on technology, but you can win on having different access and attracting
Yeah.
weird customers, just different customers that have
Mm-hmm.
that would want that. And so then you're sort of one in a 1,000, and now there are three. I wonder if it's convincing enough to get more foundries to open their PDKs up. And yeah, what was interesting too is like I think Tim made the point that at some point that like the PDK is just engineering overhead. Like it's treated like it's something like it's a trade secret, but really you're better off open sourcing it. I don't know if you have thoughts on that perspective or not, but
Yeah.
why? Yeah, should TSMC just open source all their PDKs and leave them out there?
I know one of the reasons for IHP open sourcing their PDKs, I mean, they are a publicly funded research institute. This is not a mass
Yeah,
production fab, so they really don't care about the PDK. Their main uh, task is like doing research. And they
yeah,
also figured out, well, they don't have any people to work on PDKs anymore. They got old. I think they retired some of them, and so they are like faced with a problem. They had no PDK engineers, and this is not. You just open a LinkedIn job search and search for PDK engineers. They don't exist in that. So that's one of the reasons.
huh?
I don't think TSMC are like the what is this called now? N2, the cutting edge, and they will open source these cutting edge PDKs. But hopefully for the 50 nanometer, what I heard from IHP2 is that sometimes they get questions about PDK stuff, like support questions, and they don't
Yeah,
even have the time to reply because people from the community actually have the answer. So I think that might be helpful to reduce support too.
yeah.
And
That's another like good
that's
analogy back to open source software community and how that developed too, because the cost of running support and the cost of running support engineers that would communicate with people was as expensive.
mhm.
It certainly did, make things run faster and cheaper for those. But you mentioned the interesting designs that people are doing. What are some of the interesting designs that you've seen that I guess wouldn't without open source, would they wouldn't be
Yeah,
supported or wouldn't be available?
I think like RISC-V microcontrollers is pretty cool. What the coolest part actually, I think, is the FPGAs we are certainly now seeing. So these are open source FPGAs. And Leo Moser from Austria, he just taped out one with the IHP process, and I think also with the Global Foundries, Wafer Space Run 1. So those are configurable open source FPGAs, and they also generate you the data for the toolchain. So you can also use open source toolchain to generate your bit streams.
Wow.
They are very small right now, but I mean, it's just a matter of PDK, the node width
Yeah.
and effort. So this is pretty cool.
Yeah, that is pretty cool. That's very interesting. maybe it was Matt or Tim were talking about somebody doing a full Linux system on a chip as well recently. So
Mhm.
it seems like a pretty big stride. But yeah, maybe some of those, even the FPGA, maybe it would be better to do on the 15 nanometer node size than the
Yeah.
120.
On the other side, 15 nanometers is also very expensive.
Yeah.
It's great to learn with these technologies because it's very cheap. You get wafer spaces, I think $4,000 or $7,000. That
Yeah.
is really cheap if you want to try and error designs, basically.
Yeah. It's cheap enough to take a flyer on something or
Mhm.
just kind of try something out. Yeah.
Yeah,
It's really
that's why
cool.
companies might just try, like existing companies, just try designs on those and figure out, oh, we can make our own chips. We only spend like a very small amount of money and not our entire R&D budget on a custom chip.
The amount of money they would have to spend to run a test. And so they could do more tests or they could try more things
No, I
out.
mean, the companies like, for example, Raspberry Pi, I
Yeah.
think it's called the Raspberry Foundation, they make their own microcontroller now. The what's it called? I think that's one engineer at the Raspberry Pi Foundation did that.
Wow.
So
Okay.
normally they just buy the big ones and now they make their own small ones. So there could be a company and they have
Yeah.
some engineers interested in chip design. And so they just try something on wafer space and maybe they figure out, oh, okay, we could open a department for chip design or make some custom chips. And then the
Yeah.
point, smaller companies doing their own chips in the future.
Yeah. Okay.
That's what, yeah,
That's really fun. That's a good example, the Raspberry Pi, because it's all closer on the niche application side, right? Because they do small batches of stuff. They're not for education. I didn't realize that they had done custom silicon for it, but that would be a great niche application. Daniel, thanks so much for coming on and chatting with me. It's been fascinating to talk more about open silicon and especially around the business model. So love to talk to you again soon.
yeah, thank you for talking to me. It was
Yeah.
nice to talking to you.
And if people want to find you on the web, where would they find you?
Mostly active on LinkedIn right now. That's probably where they can find me. It's the best source to get new projects or get information about what I'm doing.
Great. Well, we'll
So,
include that in the show notes so we can connect with you.
perfect.
All right. Thanks, Daniel.
Yep.